I'm the Chief Technology Officer and co-founder of the Fusion Syndicate, and I help customers accelerate business growth through AI-generated content. For more than 40 years, I've led marketing and business initiatives at Intel, FEI Company, and some innovative software firms, mostly involved in operating systems, programming languages, and development tools. I love to leverage emerging technologies to drive business results, and today it's all about AI accelerated content productivity. So, where this is coming from is after 4 decades in the tech sector, I joined up with three friends to start a marketing agency. And then in November 2022, ChatGPT came out. Two of us saw the writing on the wall. So, we formed the Fusion Syndicate to develop solutions for marketing, sales, and executive leadership. We engineer conversational AI agents that help users become orchestrators of work rather than executors of tasks. We have customers in North America and Europe, including one of the world's largest software conglomerates. And to meet their requirements for reliability, information security, and governance, we began hardening our solutions. And that's what led to our prompts as code approach, using natural language programming with ChatGPT and Copilot to build production grade agents. Now, you don't need to take notes. As an attendee of this webinar, you'll get a 6-page prompt engineering fundamentals handout, and it includes a glossary of the terms that I'll use today, a description of the development lifecycle that I'll go over, an agent worksheet that you can use, and 3 pages of frequently asked questions and answers. So let's start by talking about why prompts fail in production. Most failures are not model problems, they're design gaps. In real conversations, models default to helpful completion, so they wander off role, change formatting, and state guesses as facts unless explicitly forced to stay consistent and uncertainty aware. Production inputs are messy. If scope, stop conditions, required fields, and tools aren't hard coded, the model silently fills gaps by improvising, often leading to unwanted results. Prompts in development can accumulate rules that can't all be satisfied. The model resolves these conditions unpredictably unless you add precedents or narrow exceptions. If provenance isn't enforced, instructions for document or URL access, for example, the model can claim it checked files and tools that it didn't, or it may avoid using available tools entirely, leading to false confidence and brittle outputs. So, fundamental number one is to establish a contract with three key components. First is role or responsibility. You want to state what the agent is and is not responsible for, including boundaries like no invented facts and stay within platform constraints. The second is outputs, the deliverables and the format. You want to specify the exact artifacts to produce and how they must appear. For example, the ordering of the elements, the required blocks, formatting rules, length limits, and so forth. The third is how do you know you're done? What are the pass fail criteria for the agent? You want to define objective completion checks, all the required deliverables that are present, the formatting has been satisfied, the constraints are honored, like one question gating, which I'll talk about more, document and URL or website provenance rules, no contradictions detected. This helps to ensure smooth operation. The second fundamental is that determinism beats vibes. If you can't describe the workflow, you can't stabilize it. So a fixed step order removes choose your own adventure behavior, so the same input reliably produces the same kind of output. One question gating, which I'll talk about more, forces the model to collect missing requirements from the user instead of inventing them. If a critical input isn't present, it asks, otherwise it proceeds with labeled gaps. So fundamental two is determinism beats vibes, and we talked about the one question gating, and the third element is treating limits like scope, format, tool use. You know, the models have embedded within them tools for doing things like accessing websites and opening documents. And so intentionally using those in your prompts is what I mean by tool use. And truth rules, which we'll talk about with epistemic integrity, the fancy college term for that. Um, you want to include in your prompts mandatory parameters and not make these afterthoughts. When constraints are explicit and locked early, the model optimizes within them instead of improvising. So the big idea here is a three-part life cycle, the fusion life cycle. Build is the first part, which means defining the contract, which is the role of the agent, the deliverables that you want it to produce, the format of those deliverables, and what the criteria are for when it's done. Then you want to define the workflow, the step order, the gates, and the quality checks so that execution is as deterministic as possible. The second is reinforcement, and that means hardening what already works. So you first prototype your prompt to see that it works generally, and then you add minimal changes to tighten constraints, add guardrails, and plug known failure points without rewriting the whole system. Then you're ready to ship, to let it out. And when you do, you're going to encounter users who do different things with your prompts than you might have expected. There'll be edge cases, and those will reveal bugs that you didn't know about. And so you want to reproduce the failure so you can localize the root cause, patch with the smallest possible shim, and validate on the reproduced case, plus nearby variants to ensure no regressions. So I want to drill down into each of these with 3 slides each, starting with build. So there are really 6 steps, starting with a contract. And what that is about the role and the output. So you want to start by stating who the agent is. It's a writer, it's a subject matter expert on a particular domain of expertise, etc., and exactly what it will deliver, written output or plans or proposals or what have you. Then you want to define what's in scope and out of scope. Declare what the agent will cover and what it won't cover, so work doesn't drift. It's also important to maintain hierarchy awareness. The models themselves have rules that can't be violated, the large language models. Then as a developer, you're building rules into your prompt instructions. And then as users are using your prompt, they're providing inputs and asking it to do things. And so there's a hierarchy there of system developer and user instruction priority. And you can build into your prompt mandatory rules as long as they don't go against what the large language model permits. The next is constraints. You want to lock in non-negotiables early so that later steps can't violate them. And I'll talk more about what some of those might be. I mentioned that fancy college term epistemic integrity or epistemic stance. That means defining truth rules so that you get no fabrication. And when there's uncertainty, it's labeled. And when sources are used, they're cited when that's required. And when you can't have certainty, you want the model to use best efforts with limitations and label them rather than just guessing. And then finally, a grounding plan. This means specify where facts come from, like user inputs or attachments or the web, and how access is confirmed. If a user attaches a document, you want to confirm that the document was accessed or let the user know that access failed and then provide options for what to do about it. When available tools must be used, like the built-in tools for web search and things like that. And what happens if sources are missing or tool access fails? Again, using best efforts and labeling them accordingly, as I mentioned. So the big idea is to turn your solution specification into a workflow. You're designing a mini state machine. It begins with intake, where you're collecting from the user only what's required. And I find it's best to do one question at a time rather than overwhelming users with a whole flood of questions for them to think about and answer. And if something blocks correctness, ask. Otherwise, proceed with labeled gaps. The next step is executing steps in order. So you're going to have a process flow, a sequence, and you want to apply state locks after each one and enforce stop conditions so that things don't go out of sequence. And then finally, very important is a quality check where you want to run a self check at the end of your prompt, usually, uh, that scans for conflicts and verifies that requirements are met before delivering the final artifacts so that they're exactly done per the contract that you've built in. So the strategy here should answer four key questions for building your prompts. First, what's the output format? You want to define the deliverables up front, like the required sections, any templates that you're building in, what done looks like, and you want to enforce the process flow and the formatting with instructions that use terms like must and only and mandatory in the headings. And then what are there confidentiality constraints? You want to state what data must not be exposed or retained and how to handle sensitive inputs, like maybe summarizing instead of reproducing and things like that. The third is tool access. You want to declare what tools and sources are available and allowed for accessing documents and the web and internal files, or perhaps none at all. And you want to add deterministic triggers like if freshness matters, then browse the web. If attachments are needed, then confirm access, uh, and what to do on tool failure, as I mentioned previously. And then finally, when to ask the user for input versus proceed with the next step. Using gating rules, asking the user when a missing input blocks correctness or format, otherwise proceeding with best efforts and labeling those limitations and gaps. And again, I strongly recommend one uh, required question per turn, just for user experience reasons. So let's shift over to reinforcement. Once you've prototyped your prompt and it seems to work generally the way you want it, you want to harden the agent. And the first part of that is reducing known failure rates. So focusing on the behaviors that repeatedly break in real sessions, like role drift, hallucinated sources, things like that. And you want to add constraints and checks that specifically prevent those failures. And it's very important not to rewrite everything. You're at the hardening phase. You've already prototyped your prompt. So you want to avoid changing many variables at once. That's hard to audit and it often introduces new bugs. And the third is you want to identify the minimal root cause of any problems that you're encountering as you're testing your prompt before you ship it. There might be errant rules or missing constraints. And then you want to add a narrow shim, a little patch, the smallest possible. Plus, as I mentioned earlier, a regression check at the end to check to see that the fix sticks before delivering the output. Now, it's really important to avoid prompt bloat. There's generally a character limit with ChatGPT and with Copilot. 8,000 characters with spaces is as many as you can do. So you need to optimize your prompt instructions. It's real easy to go over that limit and not be able to uh, save your prompt. So if your fix creates three new rules, you've only patched the symptom, not the root cause. So you want to go for elegant simplicity. So there's four things to look for. Duplicated rules. You don't want to repeat the same constraint in multiple places, but instead you want to have one global or canonical rule plus short references to it throughout. Another thing to look for is long exceptions, like big nested unless clauses. They often introduce new contradictions. So you want to keep exceptions narrow, explicit, and local. The next thing to look for is brittle chains. Over-specified step-by-step scripts will fail when inputs vary. So instead, you want to use gates after each turn and invariants instead of long choreographies. And so a good thing to do is, again, as I mentioned, focus on minimal shims, the smallest targeted patch that fixes the observed failure while preserving everything else. And this reduces new bugs and it keeps prompts maintainable. So finally, on the reinforcement side, let's talk about guardrails and your guardrail strategy. It's really critical. And there's five main elements here. Scope fences are hard boundaries on what your agent will and won't do in terms of its role, allowed outputs, and making sure that no extra tasks are done. The next I mentioned earlier is epistemic integrity. These are rules that prevent fabrication and force labeling of uncertainty, the best effort and limitations instead of guessing. The third, this one question gating that I recommend, you want to collect the required inputs one at a time, stop after one question, and only proceed when the gate is satisfied. Then tool and file honesty, things like document access. You don't want any invented tool results or invented web URL source citations. So truthful handling of missed and failed access is really important and giving the user options as to what to do. If it can't access the URL that the user wants as a source, then ask the user to copy and paste from that URL, for example. And then validation hooks, built-in checks like a conflict scanner, acceptance criteria. Uh, this could be like a silent self-check section at the end of your prompt that catches contradictions and common failure modes before final output is allowed. So let's move to the third and final part of the life cycle, which is debugging, and drill down on that. Um, So debugging means issues found in the field and dealing with them. So you want to get a minimal, reliable case that triggers the failure, the inputs that caused it, and the prior state before the bug occurred. And so you want to localize the cause, map the failure to the smallest set of instructions and rules responsible, and apply a minimal shim to apply the smallest change that fixes the behavior without redesigning everything. Uh, you want to have regression protection by adding and updating a silent self check, as I mentioned, to the bug so it's caught before output. You want to validate, you want to rerun the reproduced case plus nearby variants to ensure the fix works. And you want to confirm maintainability, ensure the patch is readable by you in the prompt instructions when you come back later to update, uh, and consistent with the contract and workflow that you established as the heart of your prompt. No new contradictions or bloated rules should be introduced. So really you want to start with a bug report. What was the trigger input, the minimal user message, and the context that reliably causes the problem? And you want to understand the expected versus actual, what the agent should do next versus what it actually does. And gauge the severity and impact and rate it. Is it low, medium, high, critical? And who and what it affects. Is it user effort? Is it task completion, safety or accuracy, or time wasted? And the reproducibility means how often it happens. Is it always happening? Does it often happen? Sometimes happen? Rarely happens? And what are the exact steps to reproduce it? So you really want to focus mostly on the root cause localization. And frequent causes are role confusion where the prompt slips roles, and you want to locate competing role statements and missing boundaries. You want to have do not act as kind of boundaries in your prompt, for example. Missing constraints is the next frequent root cause. Things like unspecified format and scope and stop conditions, so behavior becomes inconsistent. You want to debug by finding steps that are missing that must only kind of wording for the requirements and missing acceptance criteria or gating rules. The next is instruction conflicts, where two rules can't both be followed. So debug by scanning for contradictions and patching with precedents or a narrow exception. Grounding gaps is when the prompt expects use of sources or attachments, but hallucinates or underuses the context. So debug by requiring document and URL access confirmation or statement of access failure states, and then what to do if missing. And finally, tool ambiguity. So unclear tool selection criteria leading to the wrong tool or no tool use or endless questions to the user from the prompt. Debug by adding if X must use tool Y kinds of statements, plus fallback behavior, as I mentioned earlier, like copy and pasting from a website. So web search is the main example, and document access is another huge one that I encounter all the time. So checklist of takeaways from what we've reviewed before we get into the question and answer period, which I hope will be very lively. Um, you want to define the output contract before anything else. What you will produce, in what order, in what format. And you want to enforce that with rules that use terms like must and only and mandatory. Then you want to hard code the sequence that the agent must follow. You want to use explicit do not proceed until kind of statements as gating. Uh, that kind of mechanics helps the conversation advance deterministically. You want to add non-bypassable constraints, things like no fabrication, attachment provenance states, access confirmation or access failure uh, alerts, citation rules about how to display the source. If it's a web URL, do you want it to be a plain text uh, URL, or do you want to accept the little tiles that ChatGPT and Copilot will output on screen? And you might want to say no URLs unless verified. In fact, you do want to say that because oftentimes these systems will just make up phantom URLs that people try to go to and they're not there. And you want to make sure to limit the scope. So that's an important constraint so that the agent doesn't just go off and start doing things it's not supposed to do. Uh, the fourth is you want to treat failures as reproducible bugs. Name the failure mode, identify the root cause, apply the smallest patch, and verify against a checklist. And finally, embed automated tests. As I mentioned, a silent self-check section toward the end to catch the same class of bug, things like contradictory rules and premature termination and extra questions to the user before the tool outputs its deliverable. So that's a lot. Um, I hope there are lots of questions. Who'd like to start?
One of them came from Daniel Green, who said, "What tools do you recommend for LLM analytics?" So they use post hog weights and balance today.
For LLM analytics. Well, what the Fusion Syndicate mostly does is works with ChatGPT and Copilot platforms, and there are tools that exist within those large language models and chatbots, uh, and also that are developed like Microsoft with Copilot has a researcher tool and an analyst tool, and OpenAI with ChatGPT has a deep research tool. So we tend to focus mostly on staying within those uh, platforms rather than other third-party types of tools.
So one from Nick says, "How do you put these rules and guidelines into practice? Seems like a lot of people are putting these into agent.md files."
Yeah. Well, so the way the Fusion Syndicate does this is in addition to the AI assistants and agents that we make available to customers for various content productivity solutions, for research and planning and writing and so forth, we have internal use tooling uh, that we use for agent development, and we're constantly improving and updating that internal tooling as we gain more and more experience with development and testing and reinforcing and debugging our own products. And so we build into our own tooling knowledge documents that include known failure patterns and uh, patches that work for those failure patterns and tests to make sure that they're working. And so we have knowledge documents for ChatGPT and for Copilot, as well as Gemini and Claude for future development that our tooling then accesses and uses in order to continuously improve.
Another one came in. Are these tips targeted for consumer AI tools, Claude, ChatGPT, or developers building the future of AI and agents, which is much less chatbot?
Right. So what makes the Fusion Syndicate different from most agent developers is that we're using the platforms ChatGPT and Copilot, and in the future Claude and Gemini as development and target platforms, so that we can use natural language programming rather than programming in Python or other programming languages. Uh, and we believe that AI is making it possible to use natural language to actually do more than what you can do with programming languages, because it's a better blend of the art and science together, because natural language is natural, and you don't have to translate it into a programming language. So we see this as a new way to do solution development, and we're committed to that approach.
Amit has a question as well. How do you use vibe code for embedded systems?
Vibe coding, generically speaking, you mean like improvisationally coding as opposed to a product called vibe code?
That's what I, yes, I believe that is what he is referring to.
Right. So I guess if you took anything from my presentation, it is that uh, we believe that applying the discipline and rigor of traditional software engineering is really critical to getting the enterprise grade uh, reliability and quality from these uh, natural language programmed assistants and agents. And so, vibe coding, just going off feeling and just, writing clever language, that might work for a small prompt where you just want it to do one little thing, a one paragraph prompt just for your own personal use. But if you're developing solutions to market to other customers, vibe coding is a non-starter in my opinion.
His follow-up question was, how do you handle trash memory due to the long conversation, due to a long time work? Make the model aware of important understandings and constraints.
Well,
Okay.
where we should see this show up is when people return to their saved sessions. For example, we have a marketing communications planner tool that customers use in their marketing departments to develop marketing communications plans. And they'll develop the plan in a session, and it might take multiple uh, sessions to complete it, and that's fine. They can build on that. That save session is like a model that they go back to. But we found that after in ChatGPT and also in Copilot, um, when you go back about 30 or 40 times to a session, you've essentially exceeded the context window
Yeah.
that's comfortable. And of course, that context window is getting bigger and bigger as we go from, both Copilot and ChatGPT use the OpenAI large language model. So we've gone from GPT-3 to GPT-4 to GPT-5, and the context window is bigger. And of course, with Gemini and with Claude, you have much bigger context windows, orders of magnitude bigger than what you have with ChatGPT and Copilot. But still, you do run into that problem eventually. And so the best way for people to handle that is um, after they've gone to a particular saved session more than a couple of dozen times, to copy and paste that whole session in a document and open a new chat and bring that document in and say, let's pick up where we left off. And that becomes a much more efficient way of handling it because the tool is able to parse and summarize and kind of self-optimize the use of the context window that way.
Okay, that makes a lot of sense. Um, Mohan has a question. I don't know if you have this readily available, but can you share an example of a well-structured prompt that meets most of the rules you laid out?
Uh, well, I'm not going to show our IP on screen or anything, um, but I can tell you that the prompts we have, whether it's for writing organic social media posts or for developing marketing communications plans or for gathering insights from the World Wide Web and turning them into actionable plans, they all tend to use one form or another of the role task format framework. So that's kind of a simple beginning. And so that contract idea that I was talking about really is embedded in the first section of most of our prompts called role, where we tell the agent what it is, a subject matter expert in strategic communications and marketing with particular expertise in the semiconductor industry, et cetera, et cetera. And you want to be as specific as you can be because that allows you to go narrow and deep. You know, the real value added of using our solutions over just going directly to ChatGPT or Copilot is that you're going narrow and deep in an area of expertise, and you have then built-in best practices that go into the next section, the task section, where you might have a series of steps where the agent is going through. For example, we have an RFP writer where if people want to respond to requests for proposal from, commercial requests for proposal with their proposed solution, we'll have steps where first the RFP is input and analyzed, and the agent will draw out of it the requirements and the deadlines and the requests for how the response should be structured. And then the next step is the agent will ask the user for a summary or an overview of their proposed solution, or it might be their URLs from their website about their product, or documents or PowerPoints that they've done as they've developed their product, and it'll then extract the key elements of that, and then it'll compare what the RFP is asking for versus the overview of the solution and generate a summary of where the solution fits and where it doesn't fit. And it'll give recommendations on how to mitigate the areas where it doesn't fit. And then there'll be another section where it'll then generate a proposed table of contents that optimizes the response to the RFP based on areas of fit and mitigations of misfit. And then, the user at each of these phases will be able to review and request changes and approve. And then the next stage will be where the tool will generate the uh, proposal for the RFP. And so that task has those three main parts of, the intake of the RFP and the solution, the comparison of the two to find where the fits and misfits are, and then the generation of the table of contents and ultimately the proposal. And then there'll be a final stage where everything is checked to make sure that all the criteria for the RFP have been met and all the forms and things have been prepared. And so that's a good way to look at the task piece. And the format piece would be then, how do you want that, in this case, RFP proposal uh, to be done? Do you, in what brand voice do you want it, and how long do you want it to be, and that what font formatting you want, that sort of thing. So that'd be the format piece of the role test format. And then, of course, we have that silent check section at the end that I talked about, where you want to make sure that all the criteria were met and everything was done without hallucination and so on before finally outputting the result. Long answer to a short question.
Oh, that's okay. I've got a follow-up to it. Somewhat relevant. Could we launch to production using only good prompts?
Uh, sure. I mean, that's what the Fusion Syndicate does. Is uh, we launched a production by packaging the prompt instructions we've developed as uh, agentic solutions in ChatGPT and in Copilot. And in Copilot in particular, it's more appropriate to use the word agent rather than assistant because the way Copilot works is it's using the underlying graph database, which connects Outlook messages and Teams chats and Microsoft Office documents and SharePoint documents that you have access through your role-based access control so that all of that is connected and able to be used as inputs and then you can output to Word documents and PowerPoint files and things uh, easily. So you have that interconnection with those applications and data, and so that's what makes it agentic, and that's why Microsoft is always talking about agentic flows. With ChatGPT you can do some of that as well, and it's not quite as dedicated to the Microsoft uh, applications and infrastructure, but uh, you don't always want it to be.
Interesting one by Caesar. Prompt engineering a science by itself, or is it the product of interacting with LLMs? To what extent may you leverage your output fine tuning those prompts?
So basically, the idea of prompt engineering as science versus art, and it kind of relates to that whole vibe coding idea that because you're using natural language and you can be clever with the way you put things to impact the behavior of the assistant or the agent that you're creating. Um, what's the balance of doing that versus the science of using these very rigorous software engineering disciplines uh, that I was getting at in my presentation? And it is a balance of art and science, just as programming with Python is too. It's just maybe the art side of it's a little bit more emphasized because you're using English and or whatever your native language happens to be. Mine is English, obviously. Um, but because you're using the rigor of these software engineering principles that I went over in my presentation, you're able to uh, gain a reasonable amount of deterministic behavior. Now, generative AI by its very nature is declarative and not imperative. You're saying what you want, not how you want it to be done. You're saying, I want plans and recommendations rather than saying, if then else, and add this number to this number and so on. So it's not perfectly deterministic, but that means you're not going to get the exact same output every time the way you would with a Python program or a COBOL program or what have you, but you're going to get the same pattern. And so there's certain classes of application where that's fine. And that's why we focus at the Fusion Syndicate on marketing and sales and executive leadership solutions, because you can tolerate a certain amount of variability as long as you're staying within the same sequence and process. But I would not recommend doing what we do for medical or legal or any mission critical application where lives are at stake, because there you want to have far more meticulous determinism.
Amit has a question, a follow-up question to the context memory limit. Can you explain how a summary document of a chat is different than the chat itself? It is the same data in context and size, so it should use the same memory by the model. His question is in order to know how to effectively make the document between stages. And also the follow-up there is how can he identify the time and condition that is good to start a new conversation with the model?
Okay, so this gets back at this idea of if you're going back to a saved session over and over again, and
Yeah.
eventually it gets so big that the context window runs out. And so what I found is that when I copy and paste one of those large sessions that had maybe 30 different times, um, and I give it to a new chat session, what the model will do is use its own judgment to parse through and summarize, and so it won't have the complete session in its mind, so to speak, or in its memory, I guess more accurately. Um, and there's pros and cons to that because it won't have ingested 100% of it uh, in the time that you're interacting. And so what you'll need to do then is say, what about, the last part of the session where we did this? And then it'll go back and look at that. And, so that's how it works. It's able to kind of move its context window along different portions of the saved documented, sessions.
Yeah,
Whereas when you're in the actual session itself that's had all those turns, it's harder for it to do that.
yeah, I've noticed that as well. There was another question here by Daniel Green. What AI tools do you use personally? Which newer or less familiar from the big three have you found really valuable lately?
Well, so as I said earlier, our focus is ChatGPT and Copilot, and I've also used Claude quite a bit and Gemini somewhat. And I love Claude, actually. I think Claude is probably the highest quality of those four in terms of the output and the care it takes in processing inputs, and it just seems more meticulous and more thorough. And I think that's why it's so good for coding, for professional developers using, Python and other languages. I think Claude and Sonnet are the preferred platform, but that's not what I do. So um, where ChatGPT really excels is its ability to handle messiness. Um, Things like if you have handwritten notes and you make a scanned image of a page from your notebook and you give it to ChatGPT and ask it to, reproduce that and work with it, it'll do a much better job than Copilot will with the same task because Copilot is set up intentionally to work with Word documents and Excel spreadsheets and PowerPoints, and it's aimed at a different um, work context. Where ChatGPT came from the consumer world, Copilot was developed from the ground up for businesses, and so Copilot excels where you want to have a more business workflow, business productivity oriented uh, uh, solution. Although ChatGPT can handle that, but ChatGPT really excels at that more kind of messy kind of inputs, and it can be friendlier and more speculative. So a lot of people prefer the experience of working with ChatGPT over Copilot because it seems to tolerate them and work with them more hand in hand. Copilot seems to be a little more controlling and often will say no or say sorry, I can't do that a lot more. um, but for business, where you're focused on information security and data privacy and reliability and repeatability, that can have some real advantages. So it all depends on what you're trying to accomplish. And where Gemini really excels is in multimodality, working really well with video and images and audio, and also taking advantage of the Google search engine and really uh, exploiting the web uh, very, very effectively.
The most recent one that came in was, what's your opinion on perplexity?
I haven't used Perplexity that much. I've used it a little bit, and I shied away from it, rightly or wrongly. I don't have anything bad to say about it, but just because the Fusion Syndicate is my focus, rather than just personal use for my own self, and our products are based on ChatGPT and Copilot, so that's where my attention has really been. In the early days, though, I did one of the other reasons I shied away from Perplexity, and I'm sure it's gotten a lot better since a year or two ago, but in the early days, I noticed that it would often give me inaccurate information. And the whole idea of Perplexity was, to combine search and generative AI in a really powerful way. And I think Google has surpassed that, where you have the AI button or AI option when you do a Google search. It does a really great job, I found, of combining generative AI and search. So I think It's just like in the early days of personal computing when uh, there were all these software companies, and then Microsoft started sort of subsuming them by bringing in things like word processing and spreadsheets and presentation. What is today Microsoft Office, and all these companies like WordStar and WordPerfect went out of business. The same thing is happening with generative AI, and I suspect Perplexity may fall victim to that.
Which I will confirm that everyone will get a recording of this session. You'll also get the PowerPoint, if I'm not mistaken, Dan. And in addition to that, you will also get a worksheet, which is really thorough. I actually looked over it, and it's really really useful. So everyone would get at least all three of those things, and then Dan, your LinkedIn as well, and anything else that you think might be helpful for everyone who attended.
We'll be posting in the next day or so a blog based on this actual presentation. So do go to thefusionsyndicate.com and look for that.
All right. On that note, thank you, Dan. Really appreciate you. Thank you, everyone, for showing up today. And with that, we'll end the session.
Well, thank you very much. Really enjoyed it.